Warahmatullahi wabarakatuh, and thank you everyone for joining this session. So tonight we are going to discuss stiffness matrix method. So I believe you have actually learned this topic last week, right? Last week and last 2 weeks. Okay, so for stiffness method, we revise back to what have we discussed last week. And actually stiffness matrix method ni kan, okay, if we refer to the textbook, it is under chapter number 14, under chapter number 15, and under chapter number 16. So if we look at to the textbook, trust structure is discussed first, because when we compare between truss, beam, and frame, by using stiffness method, truss is the simplest one lah. So that is why truss is discussed first in the textbook. Okay, followed by beam, and last one is frame. So now is week number 12. So based on the lesson plan, kalau for ECS 556, so week number 12 for frame analysis. Okay, basically truss, whether it is truss or beam or frame, so we have to do the same procedure in order to analyze, because we are going to determine unknown displacement followed by unknown reaction. Unknown displacement and unknown reaction. So we must determine displacement first, then only we can determine reaction at the support. Kalau in truss, we have to continue dengan member forces lah, But for beam and frame, the output will be displacement, and after that reaction at the support. Okay, basically, what we need to understand is about the degree of freedom. That is the most important thing, degree of freedom, because degree of freedom ni, it is important because it relates with the force and Q. Because when we want to solve the displacement and forces, kita akan pakai the stiffness equation. And the stiffness equation ni is actually Q is equal to KD. Okay, itu kita akan tengok. Dia ada physical meaning yang every student need to understand. So that you don't need to remember. Kalau kita tak really understand what is the physical meaning of Q, what is the physical meaning of D, nanti you akan rasa this topic is very, very difficult. But actually this topic is very actually straightforward compared to the others. Okay, so kita follow. That's why even though dalam notes yang Shah Alam punya ni topik dia start dengan beam, tapi saya still follow yang mana dah ada dalam buku teks. Dalam buku teks start dengan chapter number 14. Okay, most important kat sini. Okay, what is important in analysis of structures using stiffness method? Number one, the most important thing is degree of freedom lah. Degree of freedom. So because procedure, when we want to analyze truss, or we want to analyze beam, or we want to analyze frame, procedure will be the same. Because we will be using equation Q is equal to KD. Original ada Q naught. Okay, original ada Q naught, but Q naught ni dia refers to the effect. Okay, so when there is no effect, Q naught is equal to 0. So that is why we solve using Q is equal to KD. Okay, most important, degree of freedom we have to understand, because degree of freedom, so we go to the basic. Degree of freedom in truss. Okay, degree of freedom in truss. Okay, we have to consider or to count as 2. It is 2 degree of freedom per knot. 2 degree of freedom per knot means that, for example, if we have truss like this, okay, truss like this, pin and pin, Okay, what we need to do, we have to put 2, 2, 2. So that is why this one we get 6 degree of freedom. Okay, so we have to apply degree of freedom at each node. And in trust, there are 2 degree of freedom in X and Y component. This is X and Y component. We don't count Z. We don't count Z in trust because Z refers to rotation for displacement. Z refers to moment for the for forces. Okay, for forces. That is why in thrust we know that there is no moment, there is no rotation. That is why we count only 2 degree of freedom in thrust. Okay, that is for thrust. Okay, and of course we have to label 6 degree of freedom. Start from unconstrained. Start from unconstrained. Okay. Okay, what's the difference between beam? So when we analyze beam, we have to count, okay, the degree of freedom equal to 2, okay, for Y and Z component. This is Y component, this is Z component. We don't need to count X. Even though dalam beam analysis, for example, or frame analysis, beam lah especially, kita akan nampak that X in beam, we don't need to count because in beam normally horizontal force, horizontal displacement, the value is 0. So that is why for stiffness method, for beam, so degree of freedom, we have to count 2 at each node in Y and Z component. So for example, if we have beam like this, it is a continuous beam. So we label, we number, we put numbering representing nodes. Okay, 1, 2, and 3. 1, 2, and 3. If the question given A, B, C, doesn't matter. Okay, 1, 2, 3. So 3 nodes means there are 6 degree of freedom in Y and Z direction. Okay, equal to 6 degree of freedom. And again, we have to label this according to constraint and unconstrained. I normally say unconstrained first, then only constraint. Because nak bagi familiar, sebab numbering tu we must start at unconstrained first, followed by constraint. Okay. So ini yang ni beam. So how many degree of freedom? Because there are 3 nodes, because there are 3 join. Okay, we have to we will have 6, which we get from 3 times 2. 3 times 2. And of course, we have to label the degree of freedom according to unconstrained, then constrained. Okay, we move to frame. So what about frame? Maybe this one. Okay, fix. Okay, so node 1, node 2, node 3, node 4. Node 1, node 2, node 3, node 4. Okay, in frame we have 3 degree of freedom per node in X, Y, and Z direction. In X, Y, and Z direction. Because component ni representing displacement, representing forces. Representing displacement, representing forces. It means that we have to put 3 DOF at each node. 3 DOF at each node. So we have to put 3 here. Another 3 at node number 2. Another 3 at node number 3. Another 3 at node number 4. So in total, we have 12 degree of freedom for frame. Okay, because this frame has 4 nodes. 4 times 3 equivalent to 12. So means that we will produce K, which is equal to Okay, K for this frame. Okay, what we get is 12 by 12 matrix. 12 by 12 matrix. Okay, so that's the difference between degree of freedom because procedure basically the same procedure. Okay, so we have to understand the difference. Okay, the different even though dia bincang benda ni dalam 3 main topics under the textbook, but actually it is the same thing. The same thing. So stiffness matrix method, actually one of the method that can be used to analyze both determinate and indeterminate. So this is actually the advantages of using this stiffness matrix method. Sebab boleh analyze both. Itu number one. Number two, the advantages of using stiffness matrix method is we can get displacement and forces directly. Displacement and forces directly at each node. Okay, which we cannot get that from the previous topic flexibility method. Because using flexibility method, we only calculate reaction at the support. We cannot get displacement directly. Okay, the flexibility method is just for calculating reaction at the support. To get displacement in indeterminate structure using flexibility method, we have to apply a unit load method. After we have solved all the reaction using flexibility method, apply unit load method at one time 1 point only. So 1 by 1 point. However, by using stiffness matrix method, okay, using the procedure, start from procedure number 1, establish element stiffness matrices, stiffness matrix for element for members, combine to have the structure stiffness matrix, and then we apply force displacement principle. And then we will solve for the unknown displacement. Once unknown displacement have been determined, we substitute back into the equation, and using matrix multiplication, we continue to calculate reaction at the support. Okay, reaction at the support. Okay, kita nak tengok konsep dulu. So, concept and physical meaning before kita move to example. Concept and physical meaning. And of course, the concept and the physical meaning can be applied to all types of structure. Okay, all types of structure. So let's say, okay, this one. Okay. This is the truss. This is truss. Okay, this is truss, 3 element. This truss has 3 element. Okay. This truss has 3 element. Element number 1, element number 2, element number 3. 3 element. 4 nodes because element joining 2 nodes. So there are 4 nodes. Node number, okay, let's start from this. 1, 2, 3, 4. Okay. Actually, in order to determine K or to establish K, we don't need to have loading. Tapi bila kita nak solve, nanti kita akan ada loading. Displacement will only occur when there is loading. Okay, in the structure. So we put loading directly. Wait. Nanti lepas saya explain this concept, nanti kita akan tengok example from notes. Okay, let's say sini ada 200 kilonewton, 300 kilonewton loading. Okay. Okay, this is truss, yeah. So what else? Node number, element number, element number, arrow. Okay, arrow. We have to put the arrow because stiffness matrix ni is actually theory behind software. So software ni bila I believe everyone dah pernah pakai software before this, right? So when we want to build any structure in the software, we have to have the coordinate system. So we have to put coordinate. And bila ada coordinate ni, dia mesti refer pada arrow, because using the arrow we can be able to identify which node become the near end node, which node become far end node. So arrow is important. Another important things that we must put here. Arrow. And arrow ni actually, if the arrow is not given in the question, you can put the arrow in any direction that you like, but kena parallel dengan member lah. Parallel. In any direction doesn't matter. Okay, the purpose of putting the arrow is to identify near dengan far end. Because the arrow is always moving towards far end. Okay, ada arrow kat situ. And then kena letak coordinate lah. So coordinate, let's say sini. Ini saya nak ajak you untuk kita baca information. Kita nak cari physical meaning of each Q and D lepas ni. Okay, so let's say this one 3 meter. Okay, 3 meter. And then yang ni nak senang kita letak sini 4 meter. Okay, so now we want to put the coordinate. Coordinate ni dia ada pada truss and ada pada frame. Coordinate. Beam we don't have to put coordinate because under beam formula there is no need to calculate Cx, Cy or lambda x, lambda y. But we have to calculate Cx, Cy, lambda x, lambda y in truss and in frame. Beam no need. Okay, beam no need. So normally coordinate ni kita akan letak pada truss and frame only. Okay, truss and frame only. And bila kita nak letak coordinate, this coordinate, we have to choose, ini tips, okay, tips only. Normally, and the best way is to choose origin, to choose one node as origin, and we have to make sure that origin that we choose, okay, by choosing that as origin, the rest will have the positive coordinate. Okay, that is why kita akan choose one as origin. We will choose one as origin so that bila kita choose one as origin, node number 2, node number 3, node number 4, semua dapat all positive coordinate. So sini dapat 6, 0. Okay, we get 3. 3, 8, right? 3, 8. And then 4, node number 4 we get 3, 4. Okay. Okay, and last but not least, the most important is degree of freedom. And in total, there are 4 nodes, so total is 8 degree of freedom. Okay, 8 degree of freedom. Unconstrained and constrained. Okay, unconstrained and constrained. From the support, from pin support, there are 3 pin at node number 2, node number 1, node number 3. 1, 2, 3. There are 3 pin support equal to 6 unknown reaction. 6 unknown reaction. So remaining will be 2. So these 2 means there are 2 unknown displacement. Okay, yang ni kena clear. So this 8 degree of freedom, okay, we have to separate between unconstrained system and constrained system. So constraint refers to support. And by looking at the support, there are 3 pin support. 3 pin support means there are 6 degree of freedom. 3 pin support means there are 6 unknown reaction. 6 unknown reaction. Okay, 6 unknown reaction located in constraint system. So to complete 8. So means that there are remaining 2. So 2 will be located under unconstrained system. Under unconstrained system, and this unconstrained system, okay, has unknown displacement. Unknown displacement. So unconstrained is not number. Unconstrained is not number. Where is unconstrained? Not number. Unconstrained. By looking at this. Not number 1, not number 2, not number 3, not number 4. Between these 4, mana satu unconstrained? Which one? Which node is unconstrained? Which one?
4.
4. 4 is unconstrained. 4 is unconstrained. So node number 4 is unconstrained. Okay, so 1, 2, 3, constraint. Okay, constraint. So we have to label. So sebab dah penuh dalam this diagram, so I redraw the diagram. Okay, sketch only. So this is just to show to you how we label degree of freedom. Label degree of freedom. So we have 2. This is 1 and 2. 1 and 2. Okay, and then continue. Either one, you can choose this one as 3, 4. Doesn't matter. Or other friend want to choose this one as 3, 4. It's up to you. Okay, it's up to you. So let's say I want to choose this as 3, 4. Okay, I choose this as 3, 4. So this will be 3, 4, 5, 6 and 7, 8. 7, 8. Okay, so having all this information in the diagram, then only you can plan to start. Okay, you can plan your K. So you will have K1, K2, and K3. So K1, you will produce matrix 4 by 4. K1, you will produce matrix 4 by 4 because one element has 2 nodes. Element number 1, mana tadi element number 1? Okay, element number 1 yang horizontal member. Element number 1. So all this saya dah bincang in example 14.1, example 3.1. I've discussed all this. So this is just to revise it back. Okay, element number 1 yang ni. Based on the arrow, the arrow is downward direction. Okay, arrow downward direction. So from the arrow, this is near node, this is far end node, near and far. At near node, we have XY. Far also we have XY. Okay, this is 1 and 2. And near, mana near? 7, 8. 7 and 8. So from this, how we label K? So I don't want to show how we get the value inside the matrix because okay, you need to refer back to the previous video if you need to. Okay, the most important thing, of course, you kena start dengan yang coordinate tadi, calculate CX, CY, lambda X, lambda Y. And then use formula, put all the value. It is 4 by 4 matrix. But what most important is the degree of freedom label for each K for element. K1, K2, K3 must be labeled correctly. K1, K2, K3 must be labeled correctly. Okay, we must look at to the element. We have to label start from near X. Start from near X, near XY, then only far XY. Kena label this K. It is 4 position. Refers to 4 position in the diagram. We will label this as, macam mana tu label dia? How to label this? for position of degree of freedom inside the K1. Start from near. Macam mana nak label? 7. It is 7. 8. Tak tengok video lagi ke ni? 1. 2. So label ni important. If you don't put label correctly, salah semua. You have to label correctly. Dan label tu, you must follow the rules. Okay, the rules is you must start from near. Start from near. How we identify near and far and from the arrow. Okay, from the arrow. So kena label ni dalam ni. Kena label each K. We need to label each K. Okay, K2. The same, it is 4 by 4. It is 4 by 4. So where is element number 2? Element number 2, this one. Arrow is like this. Okay, element number 2 is this. The arrow is like this. So from the arrow, because arrow is moving towards far end. So this will be far. This will be near. So for each near and far, there are degree of freedom. Degree of freedom. Okay, so refer back to the diagram. Okay, it is 5612. From the arrow, it is 5612. So the label is 5612. 5612. Okay, 5612, 5612. Okay. Okay, next one, element number 3. Element number 3, K3. Again, we will have 4 by 4 matrix. 4 by 4 matrix. Okay, we calculate the value in the matrix using formula. Okay, using formula, start dengan calculate dulu Cx, Cy, lambda X, lambda Y. Okay, and what most important is the degree of freedom label. We label start from near X, Y, far X, Y. Okay, so look at the arrow. Okay. For element number 3, element number 3, so we follow back whatever arrow that we put. Because Cx, Cy also we calculate based on the arrow. Okay, so we have to put the arrow in the main diagram and we have to follow the arrow until the end of analysis. Okay, so from this, the degree of freedom will be 1, 2, 3, 4. Because this one will be near end, this one will be far end. We identify from the arrow, we label the degree of freedom. Okay, this is 1, 2, this is 3, 4. So from this, we will label K. We will label K. This K we label 1, 2, 3, 4. 1, 2, 3, 4. Okay. Because there are 8 positions. There are 8 positions. It means that, okay, we will have Q is equal to KD for the stiffness equation. For the stiffness equation, and we are going to produce the stiffness equation and all must be written in matrix form. It means that we have to write Q, K, and D in matrix. K memang in matrix lah, because from this K, K1, K2, K3, we will produce K1 plus K2 plus K3. Okay, for the structure stiffness matrix. Structure stiffness matrix, and size of the structure stiffness matrix must be equal to 8 degree of freedom. 8 degree of freedom. So this one we have to write we have to determine the value, okay, from which will be okay, we'll be getting from this 3K, terdapat from 1, 2, 3 ni. Okay, we total to get the structure stiffness matrix, and the structure stiffness matrix must be written in order. Must be written in order. Means that in the structure stiffness matrix, we use capital K. It must be written in order. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. In order. Okay, 8 by 8. 8 by 8. So this 8 by 8, okay, K 8 by 8, we will substitute into this equation. Okay, now we want to focus to these two first. Okay, Q is nodal forces. D is nodal displacement. Nodal forces, nodal displacement. There are 8 value. There are 8 value from Q1 until Q8, and from D1 until D8. From Q1 until Q8, and from D1 until D8, because there are 8 degrees of freedom. And each Q1 until 8 represent, okay, representing, okay, dia ada physical meaning. Means that kalau Q1, what does it mean? Q2, what does it mean? From the degree of freedom. From degree of freedom. Q1, what does it mean? D1, what does it mean? We know that if we label 1 to, wait. 1, 1, 2, 3, 4. Okay, here is 1, 2, 3, 4. Okay, the physical meaning of Q and D. Physical meaning. This is very important because if you don't understand this, susah untuk you identify the Q and D value. Okay, the Q and D value, because in order to solve for the unknown displacement, so semua information that is given in the question, that is given in the diagram, we have to transform into equation. And to transform the right value into equation, we have to understand physical meaning. It means that, okay, we will have Q1, Q2. Q1 and Q2. Refer to the first diagram, refer to the second diagram. Okay, Q ada dekat sini. Sini Q. Given in the question. Okay, that is Q. Okay, that is Q. Means that if we want to put the value of Q1, what is the value? If we want to read the Q1 from the diagram, Q1 and Q2 from the diagram, what is the value from this? What is Q1? What is the value of Q1? What is the value of Q1? Berapa? Q1.
200.
It is 200. Q1 is 200. Okay, what is Q2? What is Q2? What is the value of Q2? What is Q2? If Q1 is 200, Q2?
Negative 300.
Yes, it is negative 300. It means that 200 to represent what? This 200. 200 is, cuba tengok diagram tu. Okay, diagram ni. Okay, what what is the physical meaning of Q1? Q1 is, this is position 1, Q1, Q at position 1. And position 1 is located at node number 4. It means that we have to read the horizontal force at node number 4. That is Q1. That is physical meaning. It is horizontal. Horizontal ni we get from position 1 tu. 1 ni refers to horizontal direction, horizontal component. It is horizontal because it is Q, so it is a horizontal force. At node apa tu?
4.
4. Node 4. And the value is 200. That is the physical meaning. Horizontal force. Okay, Q1. Q1 refers to this. 1 refers to horizontal component. Okay, node number 4. Okay, and Q, force lah kan. So that is why the physical meaning of Q1 is a horizontal force at node number 4, which is equal to 200. Which is equal to 200. Okay. Okay, if Q1 is horizontal force, what is Q2? What is Q2?
Vertical force.
Vertical force. It is a vertical force. Vertical force at node 4. Still at the same node, it is a vertical force. It is a vertical force. Okay, because 2 refers to vertical component. 2 refers to vertical component. Okay, at node number 4, Q2. So kita carilah the value representing that statement. It is negative 300. It is negative 300. Negative because it is opposite with sign convention. 2 to upward. 2 is upward direction. 300 is downward direction. It is opposite. So that is why the value is negative. Okay, the value is negative. This is negative 300 kilonewton. Okay, so the same thing we apply to Q3 until Q8. Okay, what is the meaning, the physical meaning of Q3? What is the physical meaning of Q3? What is the physical meaning of Q3? Sini ada pin. What is the physical meaning? It is a horizontal reaction. Tadi force kan? So now dia dekat support kan? Horizontal reaction. Okay, that's how we read the diagram. We read the diagram. That is why, so Q3 until Q8 tu we get 0. So tak payah tulis lah, 0 lah. Q3, Q4. Q4 is vertical force at node number 3. It is also 0 pula. Unknown. This is unknown. Okay, sampailah Q8. Okay, so all 6 unknown reaction. Unknown reaction. Okay, yang ni Q. So this Q can be transformed. In matrix form. 8 position. 8 position 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1 tadi 200. 2 is negative 300. 6 are unknown reaction. Q3, Q4, Q5, Q6, Q7, Q8. Remain as symbol, and this will be the output, the second output. 3 until 8. 3 until 8, Q8. So what about D? What about D? Same label. What is physical meaning of D1? What is physical meaning of D1? What is physical meaning of D1? Ubah kat sini je. What is physical meaning of D1? D2.
Horizontal displacement.
Horizontal displacement at node number 4. It is unknown displacement, right? It is unknown displacement. So this is D1, D2. D1 and D2. And displacement at support at position 3 until position 8. What is the value? D3. Apa dia D3? D3
Zero.
is
0.
0 because it is horizontal displacement at node 3 and it is pin. So all displacement at support will be 0 unless there is a support settlement. 3, 4, 5, 6, 7, 8. Okay, so after we get all this, then we combine to have this what we call a structure stiffness matrix. So we write in order. We write in order. That's why we get this is the Q, K, and D. Okay, so that is for truss. 14 14.1 yang ni. Okay, so I have discussed this. Check back the video. The video I have discussed. This one is example given in the textbook. Example 14.1. So this is the question. Okay, step tadi lah K1, K1, K2 because there is only two members here, two element here. Element number 1 we get K1 in terms of AE, but we must label. Okay, see we label 1, 2, 3, 4 because of the the degree of freedom label in the diagram, and then we get K2. So K2 we label as 1, 2, 5, 6. We label 1, 2, 5, 6. Okay, we get from the main diagram as well. Okay, and then we have to combine. We have to combine to get the structure stiffness matrix, and it must be written in order. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yang ni, if it is correct, okay, the rest will be correct. If yang ni is not correct due to wrong labeling, so habislah displacement is not correct, the reaction is not correct as well. So how we get this? How we get this? So yang ni, the structure stiffness matrix ni, this is matrix. Matrix means in the matrix kan apa dia punya karakteristik, the value must be symmetry. The value is symmetry, and then symmetry kan, tengok sini symmetry ni sama dengan ni symmetry, right? Sini sama dengan sini symmetry. So it actually carries all the characteristic of the stiffness of the matrix. of the matrix. And how to get this? So dalam ni kan kita selalu sebut kalau matrix 1 1 1 2 until 1 6, 3 4, 3 5, 3 6 until 6 6. So we have to find the value. We have to find the value. For example, if we want to find the value for 1 1, if we want to find the value for 1 1, okay, so if we want to find the value for position 1 1 dalam the structure stiffness matrix ni, cari 1 1 dalam K1, K2, K3 and so on. So 1 1 dekat sini 0.072, 1 1 dekat sini 0.333. So we plus these two, we get 0.405. If we want to find the value at position 5 6, position 5 6, position 5 6, this is position 5 6. Position 5 6, we get from okay, for example, for position 5 6, so we have to find 5 6 in K1 and in K2. Okay, 5 6 and in K2 is 0.128 and there is no 5 6 in K1. So that's why we get 0.096 only. So we do like that, one by one position in the matrix. Start from 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, 1 8. If we refers back to yang tadi tu. Tadi yang mana saya tekan lupa dah. Yang ni. Okay, yang K tu. So I don't want to repeat that. You tengok balik video tu, saya dah describe quite detail under example 3.1 and 14.1. Okay. Tengok yang tu. Okay, so once we get this, then we have to solve. So bila kita solve, actually it has separator. Separator between unconstrained and constrained. Unconstrained and constrained, and whenever we want to solve, this is D1 and D2, because of the zero displacement at constraint system, when we want to solve the unknown displacement, we are actually considering only unconstrained system. So kita solve yang ni je. Because the rest, when we times with zero, we get zero. So bila kita nak solve, normally kalau unconstrained system tu ada 2 degree of freedom or 3 degree of freedom, we can solve it manually. Kalau for example unconstrained ada 4 degree of freedom, we cannot solve it manually because we solve this using simultaneous equation. Lastly, kita dapat this equation, something like this. It is only 2 by 2 because of 2 degree of freedom. 2 unknown displacement. So this one value tadi 200 and negative 300. This one is in terms of AE. This one position 1, position 2. Okay, then we solve this using calculator. Use simultaneous equation. Okay, then dapat D1, D2, and after that substitute back and you will get the mana dia? Ini. Okay, you will get, oh bukan. Okay, so yang ni 14.1, ada yang 3.1, nanti saya letak kat mana, yang actually 3.1 pun I have cover, and saya dah buat video yang cover sampai dah bincang how we calculate displacement, actually dah bincang juga how we calculate unknown reaction, dah bincang juga how we consider the support settlement, semua tu dah ada video-video dia. Video-video tu semua ada dekat YouTube, my YouTube channel. Okay, boleh tengok, and link ni selalu saya share dalam group as well. Okay, so Just refer back to all this lah, all this, and if you have any question, okay, you can ask. Okay, so that is trust. That is trust analysis, and of course in trust, if you refer to the notes, okay, this is the this one. Okay, basically it is the same process lah, the same process. Okay, this one, label, and then calculate for each element, and then this is K2, label, and then when we combine, we have like this, and when we solve, we have two simultaneous equation. And then we solve, we get D1 and D2. If AE is given, then we can have D1 and D2 in unit meter. If not, in terms of AE doesn't matter, because whenever D1 and D2 substitute back into the equation, we will get the reaction at the support. Okay, and example 2 ni is just that is is actually showing how we calculate member forces using formula. This is the formula. Okay, just refer to this formula because we already have CX CY, and we already have D1 D2, and we just need to substitute, and we get the value. It is single value because it is matrix 1 times 4 and 4 times 1. So when we solve this, multiply this, we get 1 times 1, single value. Okay, yang ni saya tak bincang detail, nanti you tengok video. Okay. Okay, about the effect of temperature changes and fabrication error, nanti pun tengok video juga. Okay, or maybe we can set another session to see the effect. Effect that we have to consider the effect from temperature changes and fabrication error. Just like we analyze flexibility method, we analyze thrust, we can consider temperature changes and fabrication error as well. And fabrication error and temperature changes ni, we must include into the stiffness equation, and we call it as Q0. We call it as equivalent element nodal forces. We have to include into the equation. So original equation tu memang Q KD plus Q0. Original equation. This is original. But when there is no effect, when there is no effect, yang ni becomes 0. So that's why we only consider Q is equal to KD. Okay, like what we have done just now. Okay, yang ni saya nak postpone dulu sebab tak nak bagi you pening lagi. Tengok yang basic dulu sebab saya nak compare dengan beam before kita masuk frame. Of course, beam ni I believe yang student from 556 dah bincang dengan Dr. Teven, tak apa. So yang ni yang okay, yang ni yang my style pula. Okay, sebab saya nak tunjuk the similarity bila kita nak masuk frame. Okay, frame. Okay. So you can find this note under this Okay, this one, and frame dekat sini, beam under part 1. Beam under part 1. Okay, saya nak continue untuk explain lagi okay, about the concept we discussed previously just now, about the concept. Okay, back to the concept just now, we have thrust. We have thrust, beam, frame, 2 DOF, frame 3 3 per node. Per node. When we move to beam, we have like this. Basically, for example, UDL. This is UDL. The value is 50 kilonewton per meter. Okay, 15 kilonewton per meter. Actually kan you have two style. You have two style to solve beam considering UDL. Okay, under my notes nanti saya akan letak juga my notes second version. Okay, the first version tu yang you get from Dr. Tever tu, the second version is from me. I will put in the OneNote as well. Okay, so most important thing when you want to analyze beam, you have to have, okay, of course in beam we don't need to put coordinate because coordinate no need, arrow no need. So what we need to have here is node number, element number, arrow tu understood dia memang going to the right direction. Okay, because we refer to the appendix. And label, the degree of freedom. So degree of freedom ni must be put correctly. Degree of freedom must be put correctly. So in order to do that, beam ni dia punya degree of freedom position is not as easy as truss beam. The degree of freedom. Okay, so by looking at this one, okay, how many degree of freedom in this beam? How many? Ada berapa semua degree of freedom?
6.
Okay, total is 6 degree of freedom. Okay, divide into unconstrained and constrained. How many unknown reaction?
4.
4. We only count 4 because at node number 1, we don't count X. We don't count X, so 4 unknown reaction. It is 4 unknown reaction. The remaining will be 2 unknown displacement. Unknown displacement. 2 unknown displacement. Yang ni, for me, the best way to differentiate. But kita sketch. The sketch. Okay. Okay, one for unconstrained and one for constrained. One for constraint, another one from unconstrained and constrained. So this is 1, 1, 2, 3. 1, 2, 3. Reaction. Reaction at the support there are 4. At node number 1, ada dua-dua tu kan. Okay, so at node number 1, we put 2. At node number 2, we have vertical reaction at node number 2, right? Because of the roller. So have one here, one vertical reaction. And another one vertical reaction at node number 3. Yang ni paling mudah kan? Kalau you nak buat, you buat macam ni. Compare dengan free body diagram that you have learned previously. So this is BY, this is CY, this is AY, this is MA, this is conventional way. Conventional way like this, right? So this is AX. And we count this as 2, this as 1, this as 1, we transform into this. Okay, so we get 4 and 2. We get 4 and 2. So if this is for unconstrained, this is for constrained. So always remember that we have to label unconstrained first. We have to label unconstrained first. Means that we label start from, yang ni satu lah, 1 and 2, 1 and 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, yang ni memang kena clear. You have to clear about this. Okay, and you have to relate this to the physical meaning. Because Q1 in this case refers to Q1 kalau kita compare dengan yang ni. If we want to compare to this A, B, C, this is BY, this is CY, AY, moment, conventional way. Okay, what is Q1? What is Q1? Compare dengan yang bawah ni. Q1 tu apa? AY, BY or CY? Q1.
BY.
Sekejap. Q1. Sekejap. Q1. Q1. No. Okay, we have 6. Okay, sini ya, sini. Okay, we have 6 Q1, Q2, Q3, Q4, Q5, Q5, Q6. Okay, 6 ni. Okay, Q1 tu dia Z direction. Q1 means Z direction. Okay, soalan saya letak diagram kat sini. Saya letak loading. Okay, loading sini tadi 50 kan? Kilo Newton per meter. Okay, I add another one. Okay, letak kat sini satu moment. 200 kilo Newton meter. Okay, what is Q1? Q1, physical meaning dia apa? Physical meaning of Q1. Macam tadi kita ada physical meaning horizontal display, horizontal force at node number 1 and node number 4. So yang ni Q1 refers to tengok pada kita ada 3 component. We have 3 component. One refers to Z component. One is this. When Z component in terms of forces, it becomes horizontal force ke, vertical force ke, moment ke? Moment. So Q1 in this case is moment at node apa tu? At node 2. Moment at node 2. Okay, Q2. Moment at node 2 ke node 1 tadi? Moment at node 1, moment at 2. Okay, Q3. Q3 yang ni.
Vertical.
Sama dengan ni. Q3. Apa dia Q3? Vertical reaction at
Node 1.
At node 1. Kalau kita compare dengan yang bawah, equal to
AY.
Vertical reaction ya. Vertical reaction at node 1 Node 1, this is AY. Okay. What is Q4? It is what is Q4? It is moment, right? Moment at
Node 1.
Moment at dia letak note ni nanti confuse. Sekejap. Moment at ni bukan 1 and 2. Betul lah tadi 2 tu. Note letak sini note confuse. Sini note 2 ni note 3. Okay. So 1 tu moment at node number 2. 2 tu moment at node number 3. And then Q3 vertical reaction at node 1. At node 1. Moment at node 1. Q5. What is Q5 and Q6?
Vertical.
Vertical Vertical reaction. At node number?
Siapa?
Node number 2. Node number 2 equal to, compare to diagram bawah?
BY and CY.
BY and CY. Yes, BY and CY. So this is BY, this is CY. Okay, this is in terms of Q, in terms of forces. What if what are the physical meaning, okay, of displacement D1 until D6? D1 until D6. Tadi Q kan? Okay, now D, displacement. Okay, in this beam, when we conventional, this is conventional way we analyze beam, right? Conventionally. So in stiffness matrix method, kita tak label all like this. Okay, we just need to I just show this to you because I want you to be able to compare, so that numbering tu you tak nampak dia as numbering only, you kena nampak dia punya behavior. Okay, you have to see the numbering tu as behavior. So kalau due to this loading, due to this diagram and loading, what happened to the beam? Is it lebih kurang kan? Deflection. It will deflect due to loading. It will deflect due to loading. A is fixed. A is fixed end. That is why when we draw the deflection, okay, deflection at A, we cannot draw from A like this. You still remember that? Because of the effective length between support, between fixed, okay, between fixed and roller. Between fixed and roller, deflection dia tu, we cannot start at A. The effective length is about 0.7 only because displacement and rotation at fixed equal to 0. Okay, at A, displacement and rotation. Ini dekat A. Displacement and rotation. Yang ni dekat B. Displacement at B, rotation at B. Displacement at C, rotation at C. Okay, what is the value of delta A and theta A? What is the value?
0.
It is 0 because of the support. Okay, what is the value of delta B? It has roller?
0.
Okay, this one also 0. Delta C also 0. What about delta B and delta C?
Ada nilai.
Yes. Okay, ada nilai. And we can actually see from the deflection that I draw, okay, there are value of theta B and theta C which we can get from this tangent. Okay, this shows deflection. This shows deflection at C. This one is deflection at B. Same. It means that D1 tu, you have to be able to see that D1 is actually represent, what is D1 from this? What is D1? What is D2? D1, D2? What is it? D1 and D2? D1 equal to? What is the physical meaning of D1? What is physical meaning of D1?
Moment.
No, displacement. Displacement, moment for forces. Now we talk about displacement. So it is D1 is equal to D1 physical meaning of D1. Apa maksud D1 tu? Dalam diagram ni dia komponen Z. Komponen dia komponen Z. Komponen Z in terms of displacement jadi rotation. Understand? Because it is Z component. Kalau komponen displacement komponen X, it is horizontal displacement. Kalau komponen Y, it is vertical displacement. Kalau komponen Z, it is a rotational displacement. Rotational displacement is rotation, slope. So D1 and D2, the first output from beam analysis, D1 and D2, if we refer to this beam, D1 is apa ni? Saya dah highlight tu. D1 is theta. D1 is
Theta B.
theta B. D1 is theta B. D2 theta C.
Theta C.
Theta C. And it depends on how you label the diagram. Okay, it depends on how you label. Kalau you nak label sini 1, 2 terbalik, dia terbaliklah label tu. This is 1, 2 terbalik. Okay, depend on how you label. So whenever you want to determine, you establish the stiffness equation first, and then you want to solve D1 and D2 in beams. If we refer to beam like this, okay, we are actually determining rotation at B and at C. Dekat roller ada rotation. Sebab dekat roller displacement, vertical displacement only 0. But not rotation. That's why kita boleh, bila kita draw tu, kita nampak dia punya curve tu. So yang kita nampak curve tu lah kita punya D1 and D2. Okay, D1 and D2. Okay, this is the concept lah, the concept for beam. Before we can apply the value into the diagram, so we have to substitute into of course Q is equal to KD. Okay, and actually we can also analyze considering Q naught kalau kita nak buat analysis of UDS separately. Analysis of UDS separately. So we get Q naught as well. So Q naught, what is actually Q naught? Q naught is actually macam ni Q naught is equivalent nodal forces. Kalau Q is nodal forces, Q naught is equivalent nodal forces. Equivalent nodal forces ni refers to member which has loading. Because member cannot carry load, UDL means UDL inside this diagram, this UDL ni akan we will distribute to the nodes equivalently. That is why we call it as equivalent nodal forces. So in the analysis, actually you can combine UDL dengan all the loading on the member combine dengan Q naught tadi tu. Okay, and you can also calculate it separately. Nanti saya akan share a few example how I actually solve this type of beam using this equation. Ada dekat previous semester punya notes. Nanti saya akan share to you lah. Previous semester punya note ada. Stiffness. So ada explanation dekat sini. Nanti saya akan clear everything and share to you lah. Share to you. So analysis of beam using stiffness matrix method. Okay. So kita nak move to, I want to move to frame. Kita pakai notes yang ada je. Okay, nanti insyaAllah I will make another session to revise again. Saya akan buat je extra session ni sampai you punya final. Okay, so you can join lah mana-mana, you can join either you are from 556 or 521 boleh join because actually both courses have same topics. Okay, tadi yang ni. Frame. Okay, so if we refer to this, the learning outcome will be the same. As I mentioned, truss, beam, frame. Sama je. Okay, the most important thing is you know how to differentiate between degree of freedom in truss, degree of freedom in beam, degree of freedom in frame. Okay, beza dia kat sini je. Okay, procedure sama. Procedure sama because you have to start with establish. You have to establish element stiffness matrices. Element stiffness matrices, after that, from that, establish structure stiffness matrix combine, and then identify Q, nodal forces and nodal displacement, as well as equivalent nodal forces, combine to have the stiffness equation, and then solve. Okay, so of course, in frame also you have to learn. You have to learn about degree of freedom, constraint and unconstrained. I believe you have understand all this. Okay, we will have to understand about the member stiffness matrix or element stiffness matrix. And then, okay, from the stiffness equation, we solve displacement. Okay, apply local and global. This is all the same. And in frame, because there are 3 degrees of freedom per nodes, so in the formula, we will have 6 by 6 matrix. This is the equation. 6 by 6. Sekejap, I try to find the appendix. Maybe we get from previous exam question. Okay, appendix. Where is the appendix? Okay, this is the appendix. Okay, so this will be the formula for K, element stiffness matrix. Element stiffness matrix, 6 by 6 matrix. Because one element consists of, this is near node, this is far node. Okay, the arrow is like this. At near node, there are 3. At far also 3. So it will be 6 by 6. And we will label the degree of freedom. Okay, start from near XYZ, far XYZ. Anyway, don't worry because, okay, normally A will be neglected. So semua yang ada A ni akan cancel lah. And actually, walaupun you nampak macam quite complicated formula dalam ni, there are so many things. And actually dalam ni, whenever A tu dah jadi 0, of course, ada CX, CY. That's why I mentioned to you just now, CX and CY is needed again in frame analysis. And actually, even though banyak-banyak ni kan, so ada 4 values only. Okay, 4 formula only kat sini. So we have 12 EI over L. it is 12 over L. It is 12 over L cube. It is 12 over L cube. Next is 6 divided by L square. And then we have 4 divided by L and 2 divided by L. Twelve, yes. Okay, so even though kita nampak macam complicated sangat formula ni kan, however, there are only 4 formula inside this. 1, 2, 3, 4. 4 ni je. Okay, 4 ni je. It is 12 over L cube, 6 over L square, 4 divided by L, and 2 divided by L. Of course, we have to solve CX and CY first. Okay, so going back to this. Okay, determine deflection and rotation. This is beam or frame? This is frame, right? Frame. This is not beam. This is frame. Okay, so this is frame. Yang ni yang kita tengok yang simple one dulu lah. Simple one I just get from the textbook first. Okay, textbook frame chapter number 16. Okay, frame chapter number 16. Okay. Okay, this one. Okay, so basically, if we refers to this, okay, note number 1, note number 2, note number 3, note number. There are 3 notes, note number. Element number, element 1, element 2. Arrow, because we need to calculate CX, CY, we have to have the arrow. So this is arrow, arrow. Okay, arrow. And then, of course, we need to have CX, CY. We have to have CX and CY. Normally, if we want to analyze this frame yang macam ni, kita nak determine dia punya origin kan? We normally do like this. Okay, we find origin at origin. Okay, so this will be the origin. So ni 0. Okay, 0 origin. So there we will get. Okay, we will get the rest of the coordinate by referring to the origin. Okay, that's about the origin. And then most important thing is we have to label according to unconstrained and constrained degree of freedom. So there are 3 nodes. There are 3 nodes. Oh, mana pergi dah? Okay, there are 3 nodes. Okay, here 3 nodes. We have roller. Sini ada roller. Okay, this is roller. Okay, this is rigid joint. So unconstrained. This one is fixed. So if we want to we label unknown reaction first. Unknown reaction. Kalau susah nak draw kan, you draw separately like what I have shown to you previously. Okay. So we just sketch like this. Okay, reaction. There are 9 degree of freedom in total. Okay, we divide into unconstrained and constrained. Under constraint, we have how many? How many unknown reaction? How many unknown reaction? How many unknown reaction? We have roller at node number 1. We have fixed at node number 3. How many unknown reaction? One at unknown reaction. Total unknown reaction. One at node number 1, 3 at node number 3. So four unknown reaction. 4 unknown reaction. So remaining is 5 unknown displacement. Okay, 5 unknown displacement. So yang ni memang kita tak boleh solve unknown displacement value, but we still can produce the structure stiffness matrix. Okay, there are 9 degree of freedom. Okay, and from the support there are 4 unknown reaction. Okay, there are 4 unknown reaction. Okay, these 4 unknown reaction ni, okay, there are 3 full reaction at here. And we have 1 roller like this. 4 kan? 4. So that's why when we sketch like this first, then we can see clearly. Kalau without these 2 diagram, you nak terus label into the main one, confused. Okay, complete the remaining. Complete the remaining means that we have to have these 3 and remaining 2 like this. Okay? Okay, so the label, okay, the label we can start 1 here, 2, 3, 4, 5, 6, 7, 8, 9. That is for frame. How we label the frame. So the first important part is this part. Kalau you label it correctly, and then you are label dalam the main diagram correctly, and then when we establish element stiffness matrices, label degree of freedom for the matrix correctly, then the rest will be easier. Okay, ada tak yang tak faham how we label this diagram? The degree of freedom. Nampak tak? Ada tak yang tak faham how we label this? Ya?
Yang kat nombor 2. Note
Ya.
2. Note
Note number 2, okay. Note number 2.
Yang apa tu? Dia macam kan dia ada macam dikira support juga ke doktor?
Tak. Dia rigid joint. This is frame, right? Dia rigid joint. Dia support kalau dia ada internal hinge. But in this case, note number 2 ni is rigid joint. Rigid joint ni bukan support. So that's why kalau you tengok kat situ, 1, 2, 3 tu, kan 1, 2, 3 tu is for unconstrained. 1, 2, 3. So kat sini, tengok dia punya explanation je. Okay, ni. By inspection, the frame has 2 elements and 3 nodes. Okay, the origin of the global coordinate system, the origin. Yang ni origin tak kisah. Okay, nanti you akan dapat. So origin tu tak kisah kat mana-mana pun. You can do like what I suggested just now. Or you can choose either one as origin. Cuma you akan dapat negative lah. Negative coordinate. Doesn't matter. So it is just how we calculate CX and CY. Lepas tu, the code numbers at nodes are specified with unconstrained D or F. Numbered first. We number the unconstrained because the output, the first output will be displacement, and displacement is located in unconstrained system. Okay. So yang ni dia tunjuk K dengan label dia DK dengan QK ni for known value. U tu for unknown value. Okay, yang ni yang tadi kita baca the information direct from diagram. So kat sini ada 5. So kat sini ada 4 DK. 4 DK means ada ini 4 DK in known value. Known value means 5 DU. Maksudnya we will have D1, D2, D3, D4, D5. 5 unknown displacement. 5 unknown displacement. 5 unknown displacement. Ada lagi question?
Ya. Ada error tak macam dia nak tentukan neo n dengan far n.
Ada error, what do you mean?
Arrow. Okay.
Oh, arrow ni normally the arrow will be given normally. But if the arrow is not given, you have to put the arrow in any direction. You boleh letak in any direction arrow tu. Dia tak ada macam bagi formula. Arrow mesti towards right direction. Arrow mesti letak ke bawah. Tak. Letak je in any direction. Arrow tu untuk kita calculate CX, CY. And untuk kita label kita punya K. Itu dia punya arrow. So kalau based on arrow ni, okay, we will label element number 1. Element number 1 we will label as, cuba tengok ni. We will label element number 1 kat sini. From this label, yang ni kita nampak sikit dia duduk separate kan. Okay, we will label element number 1. We have 6 by 6. K2 also 6 by 6. Okay, K1 tadi yang horizontal horizontal and arrow is right direction. Okay, so what should be the label in K? It is, cuba sebut 6 position kat sini. 6 kat sini. 6 label dekat, yang ni important. 6 label ni. From this. X, Y, Z. X, Y, Z. Near X, Y, Z. Far X, Y, Z. So macam mana kita sebut? Near X apa? Sini near. This is near. This is far. This is near. This is far. Arrow dia macam tu. Element number 1. Element number 1. We label as, apa nak label atas ni?
5, 4.
Kat sini kena label near. Ada 3 near Near. Ada 3 far. Near ada X, Y, Z. Far also have X, Y, Z. So what is near X? Near X is 4. Near Y? Near Y? 6.
5.
5. Continue. 1, 2, 3. 4, 6, 5, 1, 2, 3. Okay. And okay, for element number 2, arrow is down direction. So near will be, yang ni jadi near lah. This one jadi far. This is far. Okay. So how we label K2?
1, 2, 3.
Yes, it is 1, 2, 3. Followed by
8, 9.
7, 8, 9. 1, 2, 3, 7, 8, 9. Okay. So label it correctly. So of course you get 6 by 6. Don't worry, 6 by 6 tu cuma ada 12 over L cube, 6 over L square, 4 over L and 2 over L. And LCY. Okay. So 4 ni je. So put into the matrix and then combine to have structure stiffness matrix. There will be 9 by 9. 9 by 9. 9 by 9 means we will produce Q and D. Okay, it is just now. Okay, 4 unknown reaction. 4 unknown reaction means 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Kita punya boundary kat sini 4 6, 7, 8, 9. 6, 7, 8, 9. 6, 7, 8, 9. This is the boundary. 6, 7, 8, 9. 4 unknown reaction. 4, this is 4, this is 5. 5 unknown displacement. 5 unknown displacement. Okay, so there will be 0, 0, 0, 0. D1, D2, D3, D4, D5. Because condition dia between unconstrained and constrained, dia kalau belah atas dia unknown, belah bawah jadi known. Okay, kalau Q pula belah bawah jadi unknown, this is Q6, Q7, Q8, Q9. Q8, Q9. Belah bawah unknown, belah atas mesti letak value. Condition dia tu, nampak tak? Okay, kalau for displacement belah atas tu unknown, belah bawah tu mesti letak value. What is the value? Displacement at support, which is equal to 0. Okay, for Q, dekat belah bawah tu is unknown, belah atas tu kena letak value. Okay, that is why the importance of knowing the physical meaning, because kita nak cari sekarang ni, what is Q1, Q2, Q3, Q4, Q5. Because question, we can ask you until this stage. For example, establish stiffness equation for the frame. But we don't ask you to solve the displacement. Okay, memang kalau ikut prosedur tu lepas equation is solving the displacement and the reaction. Tapi in test, in final exam, boleh je tanya sampai establish stiffness equation for the frame. Macam ni lah. So still you have to letak value all this Q1 until Q5. So that is why tadi saya introduce you about physical meaning. Because you have to refer back to the position 1 until 5. 1 until 5, cari value dia in the diagram. 1 until 5. What is 1? Okay, 1, 2, 3. Q. It is horizontal force, vertical force, moment. 1, 2, 3 tu add note number 2. Ada tak value? Kat sini dia bagi 5K. Kita tukar yang ni. Dia tukar yang ni letak 500 kilonewton. 500 kilonewton. Any other value? No, only one value. Okay, so in the diagram, there is a horizontal force at node number 2. The value is 500 kilonewton. Position dia, position number 500 tu, position number Q, position number Q number 1. Position number 1. So dekat sini, position number 1, because it move, it has same with direction, same with sign convention. Because sign convention pun ke kanan, 500 tu pun ke kanan, so it is 500 positive. So the rest will be 0. So then complete lah. Complete. Write the equation. Okay, the equation. Solve. Bila kita nak solve, of course we only solve unconstrained system. But this example, we cannot solve because there are five unknown displacement, and we cannot do it manually. Okay, so okay. K1, 4, 6, 5, 1, 2, 3. And then K2, 1, 2, 3, 7, 7, 8, 9. Combine. Okay, we have Q is equal to KD. There's no Q naught here because there's no UDL. There's no point load on the member. So we can solve this using Q is equal to KD only. So we have 5 unknown displacement and we cannot solve it manually. So sampai sini je lah. Sampai sini only. Okay. there is another example, same as example in the notes. Yang ni. Okay, the procedure will be the same. The procedure will be the same unless kat sini ada UDL ya. Sini ada UDL. And this UDL we better solve. Okay, nanti saya akan, okay yang ni. Saya akan bagi satu lagi alternative solution. Okay, alternative solution for this one. Tapi ni in the next video lah. Alternative solution for this one using this Q. Q is equal to KD plus Q0. Because I want to show to you how we consider this UDL 3 kN per meter masuk dalam Q0. Okay, masuk dalam Q0 and then kita akan dapat Q minus Q0 is equal to KD and then we solve yang ni boleh solve. Okay, we solve the unknown displacement at B. Okay, dah 10:30. Do you have any question before we end this session? Do you have any question? So, yang Shah Alam punya kelas, frame next week rasa dah masuk topik baru kan? Saya check balik. Okay, tapi saya akan still continue buat session like this. Okay, before final exam lah, final assessment. And then actually there are lots of video previous actually dah banyak dalam YouTube tu, dalam YouTube you boleh refer last sem ada, last 2 sem ada, last 3 sem ada. Okay, video semua yang kita bincang on example ni lah. Okay, boleh tengok yang tu juga. Okay, if you have any question boleh direct message dekat Teams chat ya. Dekat Teams chat. Okay, dekat Teams chat boleh direct message. Because dalam WhatsApp ni sometimes takut saya termiss tengok. Okay, kalau dalam Teams chat ni sebab bila you message dalam Teams chat or Teams channel pun boleh, dalam Teams channel or Teams chat. Teams chat tu kalau individu lah, kalau you tak nak tanya dalam group. Kalau nak tanya dalam group, you boleh tanya dalam Teams channel. Okay, sebab kat situ keluar nama student mana yang message. Okay, so nanti saya akan assign juga, saya akan assign exercise for you to practice. And then saya akan bagi example solution jugalah. Okay, so yang kelas 5, so there will be no class this week. So this untuk kelas yang from kelas 5 to 1, kelas hari Rabu dengan hari Khamis. So saya dah cover hari ni. And kelas yang 1 jam as usual saya akan bagi formative assessment for you to be submitted. Okay, so next week kita akan sambung lagi lah. Kita sambung lagi to enhance your understanding in stiffness matrix method. Kita akan buat example lah. Example. So normally all example tu saya akan upload balik dalam YouTube lah. Same goes to this, saya akan upload dalam YouTube and saya akan letak link dalam Teams channel. Okay, ada question lagi before we end this session?
Tak ada.
Clear? Kena
Yeah.
kena practice. Because dia banyak term and then physical meaning tu is very important. So that you boleh label all the Q tu kan correctly, value-value tu kan. Nanti saya akan ada lagi yang saya tak sempat cover, especially Q0 pada truss. Yang mana Q0 pada truss tu kita nak tengok effect of temperature changes and fabrication error. Okay, support settlement saya dah discuss ya. Cuba tengok balik video. Nanti saya share balik link tu. Support settlement. How are we going to solve whenever support settlement is given in the question? It's okay. Okay, yang tu pun ada video. Not only video this semester lah. Last 2 semester pun ada video-video tu. And insyaAllah if we have more time, kita akan buat lagi this session like this untuk help you lah to understand more. Okay, so thank you very much. Thank you. Don't forget to tick your future. So attendance pun ada kat sini ni nanti. So thank you. Ada 40 something ya yang join. Okay, so thank you very much. We will meet again insyaAllah next week. Next week as usual lah. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam, thanks doktor.
Ya.
Thank you, doktor.
Thank you,
Welcome.
doktor.
Thank you, doktor. Waalaikumsalam. Thank you, doktor.